we're trying to create a community of with PyData. So as such, we've created also a Slack group, which is separate, and we can throw the link in the chat, and you can join if you want to be more active outside the meetup. And we also hope that we want to continue being able to do these remote friendly events, but we hope also that very soon we will be able to do to resume doing these meetups in a physical location. So maybe we can all meet together and watch this the next meetup. Cool. So I'm going to share my screen. I'm just going to very briefly tell you about NumFocus in case you haven't heard, which is the umbrella organization behind PyData. NumFocus is a non-profit that sponsors a lot of the projects behind the tools that you probably use on your day-to-day, some of which are here in the screen, like Pandas, NumPy, and so on and so forth. There are a couple of projects in the NumPy family. And one of the initiatives that NumFocus runs is PyData. PyData, I don't know where it started, but it has grown to a global phenomenon. So it there are 186 groups in a lot of countries. I was part of PyData in London. Chris was in Berlin, but we're very lucky to have PyData here in Cyprus as well, which is what we're here for today. And I guess with that, I just want to pass it over to Konstantinos, I guess.
All right. So let me share my screen. I will not keep you long, just a couple of minutes to introduce RetailZoom, basically. Let me see, how do I share? Share screen. Okay, so today's topic, can you see my screen? Basically, yes, right?
Yes.
Okay, so today's topic is very important for an organization like ours. We started off at 2011. Me and Sodiris basically kick off the company 10 years ago, and our main focus was on big data. We've been writing, mostly Sodiris basically has been writing code since. We switched languages and packages quite a few times, and along this journey, starting off with statistics and thinking that statistics is the only thing that we need to be involved with, we had to compromise a few things in order to make sure that our results are presented in the right way. So one of the most important things that we will also share today is that how exactly we need to use these algorithms about exceptional stores, exceptional data, outlier detection techniques, how we took even projects that we wrote 5 or 6 years ago, and we took a different turn in the last few years. So we are dealing with a lot of data in all these countries, and actually in the last few years it has saved a lot of time and money to the company when these algorithms perform, and when we detect outliers, whether these are coming from human errors, most of the times on purpose people try to cheat. We have mistakes from miscommunications or from electronic data structures. So being present in more than 20 countries, like I said, it's very crucial for us to have this as algorithms in place and make sure that we, let's say, track as many of these outliers as possible. So in the first part, we will show Polina will show something that we wrote specifically for a case of supermarkets and some different applications on various industries that we have. And then Andreas will speak for the part of the churn model, which we used in order to detect outlying behavior among shoppers. Okay, so I will pass on to Polina.
Hello, everyone. Just a second to share my screen. Are you able to see my screen?
Yes.
Yeah, thank you. So my name is Polina, and I work here at RetailZoom as a data scientist. And as Konstantinos said, the concept today is to talk about outlier detection. This is an overview of today's agenda, and I'll start off with the purpose of this event. The purpose for this event is to share with you our experience on how we manage to tackle a variety of business problems using outlier detection solutions. More specifically, we will show you two of our currently running projects, the approach we followed, and of course, some code. For the one problem that I will present, we used simple statistics, and for the other one, we used machine learning. The key lesson we learned throughout this process was that finding an outlier is not enough. For me personally, as a data scientist, this was weird because as data scientists, we focus on finding the most accurate model, the most precise model in order to detect those outliers. But as a business, our ultimate goal is to support our end users, our clients, in order to get all the necessary insights from those outliers. So let's move on with an introduction of what an outlier detection is. In order to define the outlier detection, we had to give a definition for the outliers. The outliers are data points that either under or overperform compared to the expected norm. Also, there is a variety of techniques that can be used in order to detect them. Also, depending on your concept, a different technique and approach might be used if you want to find an outlier in order to remove it from your data, to clean your data, and then use this as an input in your machine learning in order to have an accurate model. And a different approach will be used if you want to find the outliers and then investigate them further. Outlier detection the last few years has seen a rise in a lot of industries. And for example, let me give you a real life application in healthcare. I don't know if you are aware, but last year it was made public that 3 ophthalmologists abused the Cyprus national healthcare system by charging it 2 million euros. Actually, the algorithm worked correctly because that amount was very huge and not very common to other ophthalmologists, but was their focus only on that actual number was enough, because a different approach and action will be taken if the 2 millions were coming from 2 million procedures costing €1, and a different action will be taken if actually 2 procedures were performed and cost 1 million each. So always the concept and your goal matters. Another example is in banking. Usually banks have a threshold on the daily transactions in order to flag some red flags to the bankers to investigate them further. Let's say, for example, they have a threshold of 500 euros and a person made a transaction of 10,000 euros. correctly, their algorithm will flag this as an atypical value. But just focusing on the actual number, is it enough? No, because it will matter if that 10,000 were coming from a person that frequently made this high amount transactions, and a different action should be taken from the bank if the amount came from someone that had 1,000 as a salary and his average transactions, let's say, are 100. So again, finding an outlier is not enough. You have to see all the information and all the reasons that cause them to be an outlier. Moving on, let's see some of our own business projects. First of all, we have the sales and price correction project. This is a monthly project where we try to estimate the market share of a specific chain for the products that they sell. The order we collect the raw data is through manual transaction. So we use and build an algorithm in order to detect if the sales of the product or the actual price of the product was wrong compared to its past average trend. For example, if someone manually pressed an extra 0 for the sales, then the algorithm would flag this as an atypical value and also suggest a correction. Moving on to healthcare, we are currently working with a big healthcare organization for which we are trying to find any atypical behaving doctors and patients. Our algorithm helped us to find doctors, for example, that perform a routine procedure at a higher rate than other doctors. And also for patients without chronic diseases, flagged a few patients that their average visit frequency was much higher than the rest of the population. Another example, another project we currently have is the auditor's check. This actual algorithm checks how our auditors work. What we mean by that, because in the past we noticed some of our auditors, meaning the people that go and manually collect data from their assigned stores, they were cheating. They randomly put some numbers there, or because they didn't have time to visit the store, they used the previous month's information. And our algorithm tracked them and flagged them. And after investigate some cases further, which were consistent, some people actually got fired. And finally, the atypical stores project, which we look in more detail in the next steps. The algorithm here helped us to detect atypical behaving stores, and also to provide with all the information and the reasons why they were flagged as atypical to our end users. Atypical stores, this project is called Spotter. The examples that I will go through are applied in a large retail chain that operates in Central Europe with more than 200 stores. So imagine that we are talking about hundreds of millions of data that we had to work with. In order to tackle this business problem, we had 4 questions and an answer were given to those. First of all, we had to define the idea behind the project. The idea was that we wanted to find any atypical spikes and drops in the store's performance of that change and then flag them. It was well defined that the method we're going to use was an outlier detection technique. Our ultimate goal was obviously to find the outliers, but also be able to provide all the information and all the story to our end users in order to help them to make more data-driven decisions in order to improve their chain. And finally, we built from scratch our algorithm. Moving on, after we answered those 4 questions, we started with the building process. First, we had to use our raw data. Our raw data were daily transactions of this format, but we had to restructure them in a format that was going to keep only the meaningful information in order to get accurately the outliers. Because the information was on a daily basis, we decided to aggregate them on a weekly basis. The reason we chose to focus on a weekly basis was initially because for that specific chain, the average visit frequency of its shoppers was within a week. So the best way to represent a store's actual performance was in a weekly time frame. And another reason we used weekly data, it was in order to be able to inform our end users just on time to make an action before it's too late and how to act. Then the next step was to identify the target variables that will help us to define why a store was flagged as atypical. The key drivers were obviously the sales, the weekly sales of each store, the quantity that those stores sold, the products that were purchased, and also the number of baskets. And we looked into three different levels: at the store level, at the category store level, and at the product store level. Moving on to a key stage, it was the cleaning process. The purpose of the cleaning process was to ensure that we have quality data before moving on to building our algorithm. In order to remove the noise, meaning the false positives, and keep only the actual outliers, we set some constraints. For example, constraints we said were to exclude any recently opened stores, and also to remove categories that didn't have a lot of sales, so meaning they didn't impact the chain's overall revenue, in order to help our clients to focus their attention on important categories. And finally, using R, we managed to build from scratch our algorithm. While now it's trending to use more complex procedures, sometimes simple statistics can serve the purpose. So that's why we used a combination of statistical and rule-based approach. After we ran our code and got our first output, we wanted to test it with some obvious outliers to see if it made sense. But something there it was missing. In order to improve our algorithm, we have to think of some intermediate steps. Currently, the way the algorithm worked, it was comparing the store with its own past history. So the first idea came to compare stores, to compare all the stores of the chain. So for example, let's say if its store was overperforming in a week, then if we compare it with other stores of the chain for that week, and we saw that also those stores had the same trend, then obviously the algorithm shouldn't flag them as atypical. But then we thought about it again, and we decided to compare similar behaving stores. And the way we did that was using hierarchical clustering. Now let's see a bit of the steps we followed and the code. So as I said before, our data were aggregated weekly, and the columns here, as we can see, are each column is a store, and each row is a week, and the values are the aggregated weekly sales. We use those values and then calculated the Pearson correlation coefficient of all the pairs of stores. So let's move it a bit. So now let's look at the Pearson correlation coefficients. So this is our matrix with the coefficients. Then we used the hclust function from the stats package in order to calculate, to produce our hierarchical clustering dendrogram. Let me show you the plot of the dendrogram. You won't understand a lot because, again, we are talking about hundreds of stores, but just to give you an idea of the structure. And then a following step was to use this dendrogram as an input to the dynamic tree cut package. This package has a lot of methods. In order to define the final clusters. Let me forward. And the only predefined constraint we imposed was that each cluster should have a minimum of 30 stores. Obviously, this was adjusted for the specific chain because it's a large one. If we, for example, were applying this scenario on a smaller chain, then this number should be adjusted. And then finally, we have our clusters. Here you can see for each store, the assigned cluster. So now let's move on to a part of our algorithm, an important part. This is the part where we defined if a store was atypical or not. The algorithm is flags the stores for all the 4 target variables I mentioned before, but in order to make this example a bit more easy to understand, let's focus only on sales. And the same methods applies for all the target variables. The method we used was to build an acceptance range using 2 case fences formula, as shown in the picture below. First of all, we predefined a number of past weeks for all the stores. We needed a history. And for that reason, we split our periods in short and long-term periods. The purpose was in order to be able to capture any short or long-term effects that the target variables had on the store's performance. Moving on, we calculated the medians for both periods for the weekly sales of each store within the cluster. The reason we use the medians is because it's a robust metric and is not affected by the extreme values that we have in our data. Moving on, we also calculated the median indices, which is an indication of the percentage change between the store's current weekly sales and its median weekly sales. Next, in order to build our acceptance range, an upper and lower bounds were constructed. So we used the first and the third quantiles of the median indices across all the stores for the cluster. Again, the acceptance range was calculated for both a short-term and a long-term period. And finally, any atypical values, any atypical stores were detected if their median index value was outside the acceptance range. After we ran our algorithm, this is the output we got. So for the week under evaluation, for each store and for each cluster, we found out if the store was atypical flagged for any of the 4 target variables. with a lot of excitement, we went to our clients and presented the whole process, the whole work we did, the hierarchical clustering, the how we compared stores, how we decided to focus on specific key drivers, our target variables. And can you guess how many to how many we sold this project? I don't know if we can answer or reply in the chat, but just to make it short, we sold none. So all the work we done, all the clustering, all the cleaning, all the building from scratch was useless, because as a company, you always have to think that your clients don't have the same expertise as you. So you had to find a bridge, a language in which you can translate all this information in order for them to be able to make inference and make more meaningful and data-driven decisions. So we switch to BI tools and we restructured everything. Here, let me go to the actual dashboard. So this is the dashboard our BI team built, which provides and has all the information that the end user needs in order to make a data-driven decision. The user is control of the tool. It has the flexibility to see for which categories a specific store was flagged as a typical overperformer or underperformer, which products were sold or which products were also atypical, their past history, and many, many, many information, because outliers, these extreme values, have a lot of information and a story to tell. So with the use of the BI tool, we try to capture every part of the story and communicate this to our clients. So closing with my part, a key point here is that for us as data scientists, BI tools can translate a complex concept to non-technical audience to surface meaningful and actionable insights. So that's the end for the first part. I don't know if you have any questions, or we can move to my colleague Andreas and then have your questions there at the Q&A session at the end.
Thank you very much. Thank you very much, Polina.
Thank you.
It was found the talk really interesting, and as you said, if there are any questions now, please open your mic and ask them.
I don't know if Konstantinos wants to
add anything. Can I add something? Because most of the times we are looking for an algorithm and a solution that helps everybody without, have a software as a service. Make sure that everyone has we have a solution for every answer, and it's always the most accurate one. We sometimes have to compromise some of the things in the checks, and of course, if we are looking to find outliers for a specific chain in Cyprus or in Serbia or in Romania, different cases can be used. Our biggest challenge, though, was to be able, like Polina said, to translate the output of the algorithm into actual business execution. So by showing that the story is exceptional, the next question and the biggest question is what do they do with that? For the algorithms that we have internally, most of the times we automate the procedure or we publish the output to a specific person and we know what action to take. But when we are talking about automating and producing algorithms for clients outside the company, it's a completely different level. So we actually need to be careful on what we present and how we present the output. I see there's a question. You found the outliers based on the total weekly sales and class, and then use the BI drill down to. Yes, something like that. When we found the outliers, we not only use sales, we use baskets, we use number of items, number of categories sold, distribution of products, prices. So, like I said, when you are saying that this store is exceptional, which has 0% increase in a week, and you say that it's exceptional, we have to justify the reason for that. So by drilling down and by producing to the business the reasons why we find it to be exceptional, it's maybe because if they have loyalty cards, for example, maybe it's because they reduced the number of people going in. So the rest of the people buy more stuff. So the overall sales is stable, but you are losing people, or they are maybe buying from less categories. So there is a number of reasons, and yes, the tool has helped. If we are talking about a supermarket having approximately between 450 categories to 500, with an active product list of around 15,000 per year, you can imagine how many exceptions we can have in every week. And we publish different results to category managers, different results to store managers, and so on. So that's how we used it.
I had also one question for Polina, and it's about, at some point, Polina, you showed this very nice but quite dense dendrogram that you mentioned as well. It's very dense. I was wondering whether you use also any, I mean, I guess in the process of building an algorithm, whether you and being aware that you have to do with a large amount of data, whether you have any other visualization tool to help you not when you come to the, let's say, data product and you want to visualize it to the client and communicate it, but also internally to help you, let's say, help you build these algorithms.
I'm not aware, but I think no. I don't know if Konstantinos or Sotiris can answer this.
Visually, internally, if you try to convince Sotiris or Andreas or Polina to use a visual tool to identify their results, 99% of the times the answer is no. So although we have a couple of BI, including the Sisense one and the Power BI and all these nice graphs and charts, sometimes we do publish our results through the BI because we have a working environment internally. We publish in order to be able to see what we are looking at. But the way we do it usually is we have business people, data scientists that are involved in the business part. So we kind of split the work into people that do the algorithm and people that are more into the business and can understand and read the algorithm and then visualize and take it from there. That example that Polina showed, I remember the same with the next chapter when we presented something in Excel 7 years ago. They all started laughing and they thought that we sat down and made that up. After 6 months of work, they thought that we sit down in the before we go into the meeting and presented that. So sometimes, not often, but sometimes when we're talking about big projects, yes, we use the same tools for the that we have to publish for the clients internally to visualize our results.
Thank you. Are there more questions? I have another one then. It's related to how you build in the process of building an algorithm. I mean, it's usually somehow a very customized procedure according to the problem at hand. And I was wondering whether you follow, are there kind of, in the retail environment, let's say, is there research done and you follow parts of that, or is it a trial and error procedure? How do you go about that?
The most, I remember when we were discussing internally exactly the same thing. We gathered up together 10, 15 people and said, okay, you will write an algorithm to correct the visit dates of the auditor. So they go into the store, they capture the data for 30 days, but some of them, instead of 30 days, they put 20 or 40 or 50. So especially for the retail sector, since we have a lot of experience, the best way is to start with a statistician empirically doing manually the work. So we try to track down whatever actions they do, and we log these actions internally. For this specific example, we output a database not big, let's say less than 1 million lines for a few categories only. And we challenge statisticians to say, okay, identify manually what are the outlier detections in this database. So without knowing, they started saying, first of all, I check at the share. To do what? To see if it's important to the category or not. So this has to be documented in a way that it's not specific to the database. By checking the share to see the importance, we are not talking about if it's more than 100 euros. You have to write something that is relevant to a bigger number of retailers. So what does it mean, relevant share? If you have 100 products in the category, it means more than 1%. If you have 50, so we start taking notes, and without knowing, after 2-3 hours, we had 3 pages of comments of algorithms. So that was the first start, and we started putting this into content. From then on, of course, it's more like, because you apply this into bigger data, you find exceptions, you find areas that doesn't work. Again, we have a set of eyes that checks the output before going to the client. So that's how it's usually done. The other way, if it's something new, you try to research and understand what the rest of the companies or whatever exists out there in terms of packages, and you start checking on the different data that you have internally. And you adjust, you manipulate, and then you publish and go on. We have a lot of, that was, at some point we had to decide whether we go completely as a software as a service, or we keep that custom-made solution. It's more difficult to have everything custom, but in a lot of cases it has helped, to make it more precise.
Thank you, Constantino. If there are no more questions, we can proceed with Andreas. Okay, let's go.
All right. Hi, everyone.
Hi, Andrea.
Let me share my screen for a second. Can you see my screen?
Not yet.
No.
What about now?
Yeah, that's there.
Yes.
All right. Hi, everyone. My name is Andreas. I work as a data scientist at RetailZoom. And the topic I'm going to talk about is machine learning in business. More specifically, we'll talk about the project that we are working on. It's called customer churn modeling. It's a project that it has been tried before in industries like telecom. And I will walk you through how did we approach this, the methodology, the steps we took, and at the end, some of our conclusions. So what is churn? Well, basically, if you are running a business and you have some customers, then sometimes, depending on the situation, the customers have the option of churning, of switching towards your competitor. And therefore, we can assume that all customers have a probability of churning. And when we're talking about probability, we can approach this problem with machine learning, a classification machine learning project that we can predict those probabilities. We're doing so by building profiling for our customers using transactional data. And so the question became, given the profile of a customer, can we predict the probability of churning so that we can take some actions and prevent the churners from churning? The idea behind this project was born to the fact that it is way more expensive to acquire new customers than it is to retain your existing. And the reason for that is because if a customer is already being offered something by your competitor, then offering the same is not enough. You need to offer much more in order to regain the customer. So it's kind of buying their loyalty. So the first thing we need to do was to define some key variables. The first one is what actually is a churner. And this could be defined in a lot of ways. For example, in the telecom industry, it's pretty much straightforward. A churner is anyone that cancels the contract or will not renew the contract at the end of its period. Here in the retail industry, this definition can be defined in a lot of ways because there's a lot of back and forth between customers. Some customers may be loyal to multiple chains, and you can, for example, define the churner as anyone that does not visit the chain at all, or you can define it as anyone that visits and spends less amount than X, for example. Moving on, we need to build the training data for our model. We don't actually own any training data, so we need to build in the same way that our observations must answer the same question as we want to answer. Later on, we can do some feature engineering, some machine learning standard procedures. Then we can build our model, we can tune the model, and then evaluate the models. And we go back and forth a lot of times until we decide which model to use. So I'm gonna show you how we build our data. So first of all, we own some transactional data. This is our raw data, and what transactional data are, you can think of any observation on the transactional data representing a scan you make on the retail. So it has information about the product, it has a timestamp, it has unique customer ID, it has information about the sales and the quantity, and therefore you can calculate the price. It has information about promotion and where in which store the scan was made. So in order to build our training data, first of all, we needed to define another variable, and that is we needed to answer the question, who is going to churn within the next n days. So there's a kind of time frame here that we need to define. After we define it, we take, depending on the volume of the data, we take historical transactions, and we split the data into equally time frame windows as our predefined periodicity. And then what we do is, based on our churn definition, we go within each period and we can assign who churn and who not. So for example, Without loss of generality, let's assume that a churner means that 0 visits, so a customer will not visit at all. And let's say that on period 10, the customer A did not visit. We can go back to period 9 and assign and say, you know, the customer A will churn on the future, on the next period. So this is how we created our response variable for our model. We then needed to create some explanatory variables. We've actually created a lot of them. That includes information about sales, volumes, quantities, information about product attributes like categories, visit frequencies, days between visits and baskets, and of course seasonality. For seasonality, what we did was we built lots of linear models. We used some important variables to try to identify the relationship between those important variables with the trend. And the coefficients of that linear models is actually the relationship between them. And so we took those coefficients and we included them as explanatory variables for our big model. We've done some feature engineering. We've created one-column coding for our categorical variables. We've standardized our numerical variables. And then what we did, we needed to clean our data. So we needed to filter out some noisy data. For example, some newcomers that we do not own much information about their past, or we needed to filter out the already lost customers with very low visits or spendings, because again, the goal is to reach out to the customers that will get lost. And this is how we built our model data. Now for the training of the model, we used a package called H2O. Let me show you some code here. Okay, so H2O is an open source platform applicable both from R and Python. It's not the best package for deep learning. It only supports artificial neural networks, but it has a lot of variety of supervised and unsupervised algorithms. So this is how right now I'm defining some variables. I'm splitting them into categorical and numerical so that I can standardize my numerical variables. And now I can initialize the package, load the data into the platform, convert my response variable as being a factor, as a class. I'm then going to split my data into training set, validation set, and test set. And then what we did at the beginning, we ran a lot of, we've had a lot of hours of training and testing, and it also supports the option of auto machine learning. So it goes through a variety of algorithms and builds models and gives you the better models. So what we've noticed was that the algorithm gradient boosting machine, the GBM, was most of the time performing better than any other algorithm. So we've decided to stay on that and do some hyperparameter tuning. So here I'm defining some a Cartesian hyperparameter space. And then I have the option of either go through all the parameters combinations or just do a random search. If you go with option 2, then you need to add an argument on when to stop searching. So right now I'm just going to put 3 models just to end up this quickly. This is how I'm defining my algorithm. I'm defining what algorithm to use, my variables, response and explanatory variables, my training and validation set. So as you can see here, it has the performance bar. It runs pretty much fast. It uses Java to train the models. And then you can print and sort your models based on an evaluation metrics of your choice. So right now, I'm treating the 3 models that it builds. It tells you what type of parameters used and the corresponding evaluation metrics. Now, for the production part, what we did was we built some automated data capture system that at the end of each period, you automatically capture the latest transaction. It converts the data into training data. It built from scratch another model, and it immediately predicts for the upcoming period. We load the data into BI tool where our clients can filter based on the probability of being churn, and they can investigate their historical purchasing habits. We also have an execution tool where again we load the data, and again we can filter the risky customers and reach them by personalized campaigns with products they like to buy or recommended products. Now, I know that for every data scientist, the motivation when doing machine learning is the performance of our models. We can spend a lot of days and hours and weeks to have a better model, but sometimes in the business, we are missing the bigger picture, and that is the data and results interpretability. So we need to, the real challenge here is to convince our clients that this is actually a meaningful results that they can trust, and somehow you need to find a way to convert your knowledge into people that have enough knowledge on machine learning nor statistics or mathematics. Okay, that's it for the project. We'll now have a Q&A session, and feel free to drop your questions. Thank you.
Thank you very much, Andrea. Any questions? I can start with one. Andrea, you mentioned that you are, of course, using a lot of transactional data. That I understand that these data are used to train the models. I was wondering whether, what's the, let's say, the average amount of data you handle to train one of such models, or the order of this volume?
Yeah, so basically that depends on the retailer. For example, if we are talking about the Cyprus retailer, we can have as big as 500,000 or even some more of historical training data. And when we go out to bigger chains on other countries, bigger countries, we can even have as much as 1 million historical, not transactional data, training data.
And that's
train our model.
Yeah, and that's for the for what kind of time period are these data for? Like on a daily basis?
So we took, for example, let's say that we can take 2 years of transactional data, and we split the data, for example, on a monthly basis. So we can see on each month who churn and who not. And we can our real prediction will be on the next month.
And how does the amount of data translate to, let's say, memory? So is it on the order of gigabytes, or how much is this translated to?
Right now, I'm not sure.
I'm asking just to understand whether you can feed this data on your workstation, on your laptop, or
yeah, I think one giga RAM for 1 million, something like that.
Okay, so you are on the edge, let's say, to use them on one laptop or one good workstation.
Usually, we are using workstations.
Okay.
Can I add something on the overall risky project? The risky has always been considered as something that we publish a percentage to our clients, let's say, that these people have 97 or 77 probability to churn. In different industries, we have different interpretation of the percentage. So, for example, we are into a project now with a betting company. So you can understand a person that bets 1,000 euros and he has 90% probability of churning. This 1,000 euros is a complete loss for the company. Whereas if we are talking about in a supermarket where the percentage of profit is much smaller, different actions required. The same applies when we are talking about what is actually the probability to churn. Does it mean that these people disappear the next day from the supermarket or from the cosmetic chain? If someone spends an amount of, let's say, an average family with 2 kids spends between 400 and 600 euros. So if they spend that continuously every month, and we consider them to be 90% risky, and they actually spend 30 euros next month, which is actually something, they are still considered as churners. Now, the way we enhanced and we converted it into an outlier detection module is the fact that when we predict the probability, we need to also justify why these people are risky. So if someone is risky because they reduce the frequency, or they reduce the average basket size, they reduce their quantity, or different variants, we need to communicate that to the client because they need to take different action. I remember during a few years back when we had the huge fall of the banks and everybody was spending less, the first thing we noticed is that if we used the sales, we noticed that a lot of people had a huge decrease on sales, but the quantity was actually not changed. So by we had to switch from sales to quantity in order to make sure that people still bought 100 products, but they bought cheaper products. Or another example was that when people started spending, they went more frequently, and they spend in order not to go once every month and spend 500 euros, they went 10 times and they spent 50 euros. The actual result on the sales of the month was they didn't spend 50 euros precisely every period. So they spent 51, 52. So at the overall expenditure of the month, they went up. They actually increased more money. They spend more money in the chain. So we needed to communicate that they are risky because they changed that habit. They are buying less categories, so they're probably buying toothpaste someplace else, but the overall money is fine. They are still spending with you, so you don't need. So the actual explanation of the algorithm in terms of what the percentage mean is where we use different variables to explain to the customer.
There are some questions also in the chat. One
yes.
from Andreas. I guess Andrea's question has more to do, so I can read it so we have it also
please.
For everybody. So concerning the promotional strategy, so Andreas asked, and KPIs based on models, could this work on a societal level with project-related dissemination and outreach activities, given that we have meaningful statistics from the overall population of a country or countries or aggregates, example given Balkans? And if so, how much and what type of data would we need to use to train models in order to have a good approximation? And I guess that the question has to do with the amount of data needed to train a model and have a meaningful model, I assume.
Okay, that's a bit tricky because for every, especially with promos, promotional strategies and KPIs, we have a lot of times, being asked how you train a model with the information that we've given. So we need to have the most important thing is to have the whole of the actions affecting a specific project. So the definition of the project, what we are trying to achieve at the end of the day, we need to make a very good analysis on which variables we need to use. Promotional strategies and promotional activities, for example, the reason that is very complicated, and sometimes no matter how many data we use, is because there are always factors that affect your own data and your own performance that were not driven by you. So again, we come to the conclusion how accurate the model is. Of course, we can use these activities and the statistics and the population of the countries and so on. The more information, the better the approximation will be. But we've seen that if you want something quite accurate, you need to spend a lot of time and a lot of money, which most of the times becomes, irrelevant for the companies, and they're not willing to pay for that. What else is it described in the question? Did we answer or not?
I think Andreas can tell us, but I think I would say yes. And there is another question from Julie. Let me read this loud as well. I know that Sodiris has answered it or part of it, but let's say it out loud. So Julie asks if have you had the opportunity to test the added value of such models by doing an analysis 1 year after implementing the solution, whether the actions to reduce the churn you predicted actually worked, for example?
Yes. Okay. Another good question. There is always how do you test whether these are churners or not, and how do you test what action they have taken? Because when we provide a churn is part of the overall CRM project. So we have a lot of actions going on at the same time. The best way to check is at a specific point of time when you do a test and control and group, and you manage to see the impact of the results you have done at a specific point of time. If you wait a year to check whether these people actually responded, we are talking about thousands of promotions, points on the card, communications, leaflets for one or another purpose. So it's quite difficult to understand whether there was one reason behind the non-churners or two. We definitely noticed that if you do nothing and you lose them, it's much more difficult to get them back. Whereas if you do something quite quickly, when you have a probability, that's why I said before, we are discussing today internally whether usually models keep probabilities more than 50%. But if I have a customer that spends 1,000 euro in a supermarket and he has 49% probability to churn, I'm not going to let that guy go and wait for the probability to go 80%, because then it becomes more and more difficult to offer something to get them back. So it definitely does work. And one way we check it anyway is we predict the previous month from the previous month when we actually have data and test it. And a very big difference again with the clients is some clients consider different, let's say, thresholds for a customer to become a churner. So something that for you might be considered a churner for the customer is not, and the other way around. This year it's been very difficult to test with all this corona stuff. We had increase in toilet paper by 120%. We had increase in pasta by 100%. We've seen the consumption of specific categories and grow by huge numbers. So we are trying to be a bit careful of whether we consider someone to have a success on the actions we've made or not.
Thank you, Constantino, for the nice answers, for the very informative answers. Any more questions? Okay, then if we have no more questions, then let's thank again Polina, Andreas, Konstantinos, and every one of you that you attended. It was a really nice event, and we really thank you for that. And as always, please reach to us if you want to give a talk, and we will be in the Slack channel if you want to ask more questions to RetailZoom. Some of them will be inside, and they might be able to discuss with you and answer more questions. Thank you very much.
Thank you very much for having us.
Thank you very much.
Thank
Ciao.
you.